For today, this is our agenda. We are going to be looking at what data is in the first place. We are going to be exploring some types of data, specifically data that might not be your more traditional tabular data. Then we will go over a bunch of different skills that are important when working with data. We call it a web of data skills, and we will explain why. Then we will talk a little bit about some red flags and how to spot them when it comes to data. And then we will have a wrap up and our Q&A. Next slide, please. All right, so this is our web of data skills. And we have chosen this visualization to kind of highlight the interconnected nature of all of these things that happen when you are working with data. So it is a very good thing to start at the top with the planning, but everything else, and even the planning, it's usually iterative and it's not linear, and you will find yourself going back and forth between all of these activities. So rather than put this into a linear kind of cycle, we chose the web imagery again to highlight the interconnectedness. And in today's session, we're going to talk about each of these different components. And with that, I'm going to pass it over to Anneliese, who will talk to us about what data is in the first place.
Awesome, thank you. Starting with kind of what is data, it's a really nebulous term for a lot of people. And when you say data, a lot of people think of immediately numbers. And I know I always associated data with math and was easily spooked away from it and kind of didn't want anything to do with it because I'm not a numbers person. I've always been on humanities sides of things until I realized that data is a lot more than I expected it is. So just looking at a couple definitions, you can see just how broad the definition of data really is and how many people define it differently. So here from StatsCan, data are facts, figures, observations, recordings, and they can take many different forms: images, sounds, text, physical measurements. So really anything, but they can be gathered and processed in order to form conclusions. And that's really the key here, is they're kind of that background corpus of information that we're using to kind of think through things and form those conclusions. But then we have another definition, and you can see immediately this one is much longer, going into facts, measurements, recordings, records, observations, things about the world that are collected by researchers, things that are in various different stages. They might be processed, waiting to be interpreted, waiting to be analyzed. It can take many different formats or mediums: writing, notes, numbers, symbols, procedural manuals, data processing algorithms, or statistical records. So you can really see here the breadth of what we consider data, and starts to get you thinking of maybe you do have data if we're looking at drawings and designs of graphical representations as data. Maybe when we think about data, we think really narrowly about data. So I encourage everyone as we go through this to kind of think broadly about what data exists around you and what data you might be working with in your own research. And when I think of data, I often think right away of data are numbers on spreadsheets. And as soon as something is not a number on a spreadsheet, it's not tabular data, it becomes harder to work with and harder to conceptualize. So I know lots of people will say, is that text document really data? So encouraging everyone to kind of think outside the box here as we think about what data is. And yes, it is very much so numbers and tabular data that exists in spreadsheets, but it's also much more than that. And how we interact with the world around us is really interactive with the data around us and what we use there. And I will give it back to Antonio to talk about some different types of data that we see around us in our everyday lives and in various types of research.
All right, so I guess I will qualify some of this that Anneliese just pointed out in terms of definitions by also specifying that there is data and there is research data. So we are usually focused a little bit more on the research side of things, and research data really just adds another layer on top to the definition, meaning that you have a question that you are trying to answer. So once you have a question, like anything that you use to answer that question becomes your research data. And I have some examples on the screen of non-tabular data. So at the top, you see a little transcription of a conversation. Now, if you look at it, it has strange punctuation marks and things that might look like this is not clean data, that maybe it needs to be modified. In fact, this data is already cleaned up and analyzed. And all of those strange symbols have linguistics meaning. So I can see with the square brackets, for example, that there is overlap in the way that the speakers are interacting with each other. I can see when there is no pause or pause in the sentences. So all of this is not tabular data. It has already been analyzed, and it is really focusing on a very, very specific conversation, looking at specific linguistic characteristics. Now, if we wanted to take this into a bigger corpus linguistics analysis, maybe all of those symbols would become problematic at the time of analysis. So we would have to decide whether or not we want to keep them for analysis purposes. But again, that will depend on what your research question is. One last thing that I will highlight about that particular data set, you see the names of the people interacting. Those names were changed from the original participants for anonymity purposes. So there's a lot of planning and thinking that goes into working with research data. On the bottom left of your screen, you will see some pictures. They were generated by AI in answer to the research question, what do librarians look like? And so this is a couple of images that were generated by AI to answer that research question. And again, when we start thinking about non-tabular data, sometimes we also have to think whether that non-tabular data eventually has to interact with tabular data. So for example, if we just have those two images, maybe we can have some conclusions around the visual motifs that we are seeing. But if we had a larger set, maybe we would want to start counting, for example, the perceived age or the perceived gender expression of the librarians or the patrons and things like that. And so maybe we want to start quantifying certain things, at which point maybe we create a separate data set to complement these images. And then on the top right corner, you see a dress. Now, obviously, this is a picture of a dress, but imagine that you have the dress in front of you. There's research in fashion that has very interesting, ways of approaching how we think about clothing items. So, for example, you can be looking at things like the textiles from which this dress was constructed, the construction methods themselves, whether or not the garment has been altered, if there is a label to tell you the designer or the company created the garment. So again, there's different things that we could count as data that are not necessarily immediately apparent to us that they are data. But again, when we have a research question, it's a little bit easier to target data, because then we are looking for anything that will help us address that question. So next slide, please. We're going to now start looking at some of the data skills that we showed at the beginning, starting with the planning. But before we do that, I'm going to talk about a sample data set that we created for this workshop and an upcoming workshop. So when we were thinking about this particular workshop, we found a data set on Reddit that consists of information about hourly wages for co-op students at the University of Waterloo. And we thought it was a really cool data set. The set is crowdsourced. It is kept on a Google Sheet and it is shared on social media, in this case, Reddit. And as far as we can tell, there is just one copy of that spreadsheet. So we cannot ascertain that for sure. But we reached out to the people who were responsible for creating that data set, asking, hey, would it be okay if we use your data set to teach some workshops about data? And we didn't get a response. Now, when you are working with data, it is important to consider that there may be a need to have an ethics review or things like that to see whether or not you can collect or use data. And sometimes like there might be things that from the ethics review perspective are okay to do. So if this is on a public website, if it's, you know, being made available for everyone, then maybe you don't need any special permissions. Like I use like maybe very intentionally, but like then there is your own ethical and, you know, research standards. So we didn't think that it was appropriate for us to just grab their data and start using it to teach without their permission, especially because we did reach out. So what we ended up doing, we created a synthetic data set. We used AI to generate a similar data set to the original. We iterated through different prompts, and we tried to replicate some of the patterns that we observed in the original data set. But we were not necessarily trying to replicate the distribution of the values. So if you were to analyze the original data set and our synthetic data set, you might not get the same kinds of things, but we were just trying to use it primarily for teaching purposes. You see in this slide, like the slides will be shared, there is a link to the original data set and to the synthetic data set. Next slide, I think, is Anneliese.
Yeah, and thinking about planning as we go and plan a project, like Antonio's already mentioned, it's really important to remember that what you're doing might not be linear and you might need to cycle through the stages as needed. And planning is very much so the same. And we create things called a data management plan or a DMP to help us work through that kind of iterative process where we're tracking what we're doing. So there's a history and a written record of everything we've done for a project and everything we're planning to do. But it's also really important to think about your project holistically. So planning for what you're going to need at each stage at the beginning of a project, and really thinking about what data do you need to collect for the analyses you want to do on that. Something that's really common is people collecting kind of all of the demographic data that you see that's standard in surveys and just collecting that for the sake of collecting it. But maybe you don't need all of that demographic and it doesn't add any value to your data. And when we're looking at data sets, especially those who have human participants, it's a lot easier to de-identify or anonymize data that doesn't have that information rather than trying to anonymize or de-identify data that does have that information, because now you have that extra variable to account for. So really thinking holistically about your project from the beginning of how am I going to collect this research? What analyses am I planning to do with this? And what data do I need to collect to enable those analyses? And thinking about maybe down the road, do you do additional analyses that collecting additional data might help for? And how does that factor into your ethics review and consent forms? But really thinking broadly from the beginning of a project, what do you need to collect for that data, or what data do you need to pull together to really do to answer your research question and think about what you're doing? And also considering any research partners you have and if their policies differ. Maybe they have different ethics review processes. Maybe they have different privacy restrictions if you're working with a European school. And always considering Indigenous data sovereignty. And if you're working with Indigenous data in any capacity, who needs to be involved in those research processes, who should be involved, and thinking about that holistically through the process. As well. And I will pass it back to Antonio to talk about planning for this mock data set in particular.
All right, so we are just like in this slide, basically modeling some of the planning steps that we took for our data set. So our research question, and I use quotation marks there because we didn't necessarily want to answer a research question, let's say around wages for co-op students or things like that. We had more of a practical application. Can we find an interesting data set that we can use for instructional purposes, but it's not necessarily intended for analyses? In obtaining this data set, as I said, we reached out to the owners of the data set. And when we didn't get a response, we created our own. And then there were no partners or other people who have to interact with this data. And there is no Indigenous data sovereignty considerations for this particular data set. Now, in doing all of these planning steps, we were also thinking again about how will we use this for other instructional purposes, such as cleanup and other things. So again, like here is just like a very high level modeling of what we did in our planning stage for this data set. Realistically, could we have used a different data set that already exists out there in the wild? The answer is yes. But why are we going to make things easy for ourselves when we can go the hard way? So that's what we chose. But that was a researcher decision, and it was all planned. Could I have the next slide, please? So this brings us to very nicely to the process of obtaining data and obtaining or creating data. So when we think about working with data, there's a spectrum that goes between obtaining something that already exists or creating something from scratch. So sometimes the data that we need is going to be readily available in repositories that can be academic or non-academic in nature, government sites. In our example, there was a data set that was available on Reddit. So in those cases, maybe all you need is to just grab that data and use it. Sometimes you might need permissions to use it, but basically all the data is there waiting for you. And then we move on to situations where maybe the data set already exists, but it has to be requested because it's either behind a paywall or it has to be produced or generated for you. So for example, last year we taught some workshops using Spotify data, and that data was our own data of usage of Spotify. And that data is available and they allow you to request the data, but you do have to go through the process of requesting the data. The library, for example, subscribes to some databases that allow for some text and data mining, but again, you have to do a request to be able to do that kind of work with the data. And sometimes doing that will come at a cost, and that cost can be direct or indirect. So direct is you have to pay out of pocket. Indirect, it can be something that maybe the library is subscribing to a database and we are the ones paying for it, but you as the end researcher don't see that cost reflected on your budget that you do for your grant. Then there are situations where the data already exists somewhere, but it has to be curated or aggregated into a data set. So for example, if you wanted to find out the prices of certain groceries at different grocery stores, maybe you do some web scraping or you use some APIs to pull the prices of different products from the various grocery store websites. So you are generating your own data set out of something that already exists. Or maybe if you're not working with tabular data, maybe you're working with historical documents or things like that, and you need to digitize or convert the format of the data that already exists somewhere else. And then last but not least, data collection, like primary data collection, and or synthetic data creation, as in our example. Now, I put an asterisk on synthetic data because in a very, very strict definition of synthetic data, that data should actually mirror like the characteristics of the original data set. So if you were to do the analysis on the synthetic data, you would see results that are reflective of the characteristics of the original data set. In our example, as I said, we were not trying to replicate the exact distribution of values of the original data set. We were just trying to imitate the textual strings that you find with all the messy characteristics that they have for the purposes of cleaning. Could I get the next slide, please? All right, then we move on to the describing stages of data, working with data. So you can describe your data in different ways. The two main ways are describing data within your file, and then there is describing data outside of the file. So within the file, things like your file names, the file versioning, the names that you use for your variables, if you're using any unique identifiers, Those things will help you describe the data that you're working with, and it will make it hopefully easier for people using your data set to understand what they are looking at. Could I get the next slide, please? So the other part of it is like describing your data externally to the files. So maybe you have a README. You should have a README, in fact. And there is, a file where you collect general information about what the data set title is, who the authors were, just like a general overview of the software that you used, the file naming conventions. When you talk about software, you should also talk about versions of the software, because sometimes if you use, let's say, an older version of a particular software, might not be compatible with a later version. So thinking about like all of those things. In your README file, you will also include things like access and usage and sharing information. So who is allowed to use your research data for what purposes? You will usually describe your methodology and then your data-specific information, which can also be understood as a data dictionary. So the data dictionary can be in your README or it can be a separate file. And basically, that's just where you indicate in detail what the different variables that you are looking at are, what data types you're expecting to see in each of the fields, whether a field is repeatable or not, and things like that. And then you may have other documentation that documents specific decisions for recording your data. So for example, if we go to the next slide, you can see that I created a README description of the data set that I produced synthetically. I included in my README file a disclaimer that I was using AI to create the data. And then a separate file I used to document the prompts that I was using to generate the data set. And so all of that is available as a package that people can look at and download and understand what we were trying to accomplish. Could I get to the next slide, please? So another very important part of the process of working with data is cleaning, and I have included a QR code there for a separate workshop that is part of this data journey series, where I will be talking in more detail about cleaning. But cleaning, it's really like the very important thing that you should remember when it comes to cleaning is that it's always going to be relative to your research question. The cleaning can involve looking at the different file types that you have. You will typically look at normalizing values, identifying missing values, doing deduplication. And the process can be either manual or automated, depending on how messy your data is. And also important about cleaning, and again, I will go into much more detail in the cleaning workshop, but cleaning really overlaps with all of the other data skills from the web that we talked about at the beginning. So could I have the next slide, please? So this is like perhaps a little bit too tiny, and I apologize for that, but this is an example of the data set that we produced with examples of wages, hourly wages for co-op students at the University of Waterloo. So if you take a quick look on the left column, you will see that the company name, which is fictitious, it is differently, different spellings. So it has capitalization at the beginning, then there is instances where it is capital and lowercase. Some of the fields have additional information, such as the province where the office is located, or the particular role that a person was applying for. Again, these characteristics mirror the original data set. So in the second column, you will see things like USD or Canadian dollars. You will see ranges. You will see different information that is not just a numeric value. And then the benefits column has some rows with information and some rows that are empty. Could we get the next slide, please? So as we start cleaning up that data, some of the things that you might be looking at is normalizing the spelling. So you see that I have done a little bit of cleanup to normalize the spelling of the company name. Then I've created a separate column to do information about the location where the office is. And then I created even a separate column to indicate some roles that were included in the original column. Then I created a next column to talk about the amounts, the currency, the time unit, and so on and so forth. And you will see that I included some flags on rows 3, 4, 6, 7, and 10 to 14, because those ones were not straightforward for cleanup purposes. So you would probably either need more cleanup, or you would probably need to decide whether or not that's data that you can work with. Could I get the next slide, please? So analyzing goes hand in hand with cleaning, because when you are cleaning, you are at the same time analyzing your data. But when you get to the analysis stage, you are also thinking about other questions, such as obviously your research question and what data will you need for your analysis? Will you need to parse it out or create subsets of your data? And whether or not the data is in the format that you need. Could I get the next slide, please? So in this example, I did like a little visualization of some of the average hourly wages for co-op students in US dollars. Now, this is not a great analysis. Again, that was not the purpose of the data set, but just to highlight a few things of the analysis that was possible with the data set as it was, some of the hourly wages were recorded in Canadian dollars. Some of them were recorded in US dollars. And so in this example, you see US dollars, but it excludes some of the Canadian dollars wages. And so you will start to question yourself, like, what am I exactly looking at? And is this data relevant for the research question that I have? You can start asking yourself questions around, for example, if this is co-op students from the University of Waterloo, would it be better to convert the currency to Canadian dollars instead of US dollars? Things like that. But again, it will ultimately be dictated by what your research question is. Could I get the next slide, please? So when you are evaluating the data, you are, again, like this is very linked to the cleaning process, but it can also be its own stage. So really you are trying to get a bigger picture of understanding what the data is in the first place, and also identifying things like bias or gaps, as well as any inconsistencies or limitations for data cleaning. But again, like as I have been repeating for each of the stages that we've talked about, everything should be done for the purpose of answering your research question. Could I please get the next slide? So here again, I am looking at the same data set before cleanup. And so if I were doing some kind of evaluation of the data, I would probably go column by column, identifying different patterns and different things that I would have to clean up later. I would be looking at things like, let's just for the sake of argument say that my personal research question is, what are the companies that hire the most students from the University of Waterloo? So in that case, maybe it is completely irrelevant for me to clean up the salary information and the benefits column. Maybe I just focus on the company. But then we look at things like bias and gaps in the data. So this is self-reported data. So only people who actually filled up that spreadsheet would be counted, and so maybe it's not a representative sample. So like having all of those questions in the back of your mind as you're trying to answer your research question. Next slide, I believe, might be Anneliese's. Over to you.
Awesome. And then kind of wrapping up our web and kind of the various different stages, and again, you do some of this at each stage, is kind of data storage and sharing. And you do want to think about data storage throughout the whole process of where you're keeping that data, how much data you have, who needs to have access to it. But especially when you start getting to the sharing stage and kind of the end of a project, thinking about who needs to have access to the data, who should have access to the data, who needs to consent to data being shared or stored on which servers, and making sure that appropriate consent is given, especially if you're doing kind of human participant data and there's sensitive information there. What does that consent process look like, and what have people consented to? Again, considering Indigenous data sovereignty here and who should have access to the data and who should be stewards of that data, and thinking really carefully about whose data is it? Not just who should have access to it and who needs to consent to sharing, but really whose data is it that you're looking to store long term? And then also thinking about what supporting documentation is needed so that people down the road, yourself included, can look at the data that you've stored and work with it again in the future and either replicate what you've done or repurpose the data set if possible. And thinking about what information would you need to have if you were going to do something with that data. Maybe it's some documentation about the various variables, like Antonio's mentioned, READMEs and data dictionaries. But maybe it looks like something else for your project as well. In looking at this application that we did here, so we really wanted to make sure that we had wide access to the data for both internal and external users. So when we thought about what platforms we use, the University of Waterloo uses OneDrive, but that's not really convenient for sharing things outside of the institution. So when you're storing data, thinking about these things is important too, of who will have access and what credentials do they need. And we wanted to make sure it would have a license for reusability so people could take that data set and teach with it in the future or remix it as they see fit, and really that license was covering anything people wanted to do with it and that the documentation supported that. So the data set is synthetic, so it didn't have any restrictions for sharing, and that's one of the benefits of why people might use synthetic data in health research, because it might have fewer restrictions because it is synthetic. It's representative of an original data set, but it doesn't have those same privacy concerns all the time as that original data set would. And we also needed a platform that would be able to host the documentation we needed. So we wanted the README file, a license, but we also really wanted to make sure that we created some sort of documentation that housed how we created the data set, since it is synthetic. So we do have a document that has that list of prompts there so people can see how we did that. And this really creates kind of that log of what we did to create the data set, which contributes to the reproducibility and the transparency of the data set. We're not just saying that we created this data set and you have to assume kind of how we did it. We've documented that process of what we've gone through to create the data set that we've put on GitHub for people. Oops. And then getting into kind of the data red flags and how to spot them. Antonio's kind of talked about those biases. And those biases that we see in data are really important, especially right now where we're inundated with data and information every day. And it can be really hard to kind of spot those biases or red flags or questionable things in data. And I do want to acknowledge that spotting these kind of red flags in 2025 is really hard. And it's increasingly harder as we kind of exist in this digital world. And there's a lot of reasons why. I've summarized a couple here, but we're constantly being bombarded with information and data from various different sources from everywhere, every corner on the internet and in person. And really anyone can post on the internet about everything and anything they want. So it's really hard to kind of parse through who is a good source of information and who is an authoritative voice and who is acting like an authoritative voice. So that can make it harder to spot some of these kind of red flags and biases here. We also see an increase in fake and misleading AI generated content. And as we see an increase in how good AI is, we see an increase in kind of the quality of this AI generated content. And that makes it even harder because now it's not just kind of a very obviously fake AI generated image. You really have to look at a lot of them, and there are subtle differences, but it can take a lot of trained eye and a lot of kind of practice to spot these things. And it can be intimidating to kind of go to the internet and think about, am I seeing content that is real or am I seeing AI generated content? We also have a significant decrease in the time from an event happening and news about it reaching not only people close by, but the entire world. So we used to see kind of a lag time between when something happened and then it would be published in newspapers or textbooks or other dissemination formats. But really now something happens and then the next instant it's on the internet. And this kind of creates this increasing problem. How do we spot these red flags in data and biases in data when there's no checks and balances and things can get out there immediately? We also see an increase in political polarization, and this has been happening over a number of years and decades, which does create those biases, because you do see that contributing to where data is coming from and how people are viewing it. And also an increase in reliance on social media for news. And this is a way a lot of people are getting their news, but we also see issues where some news sources aren't available on different platforms in different countries. So this in and of itself creates types of biases, because you're not able to access all of these resources on social media, and the algorithms contribute to that as well. You're really at the mercy of whatever algorithm on whatever platform and what it's sending to you. So this creates kind of a bit of an echo chamber and biases that way by sending content that's similar to other content you've seen. So there's a lot of reasons why it's hard to spot it in 2025, but there's some things and questions to consider as you kind of consume content on the internet and data in various formats that help you become a little bit, increase your data literacy skills for not only data you're working with for a project, but just data in the world around us as we live in an increasingly datafied society. So some things to consider when you're thinking about the source of the data. Who is the source, and are there any conflicts of interest, and have they disclosed any funding? And what does that funding look like? And this may or may not be problematic. You can see a lot of private companies might sponsor research on products that they make, but maybe that's where the funding comes from. It may or may not be biased, but it's certainly a question to ask yourself. Is it a reputable source? And why is it a reputable source? So thinking about, is it reputable because someone told me it's reputable, or is it reputable because they have the credentials to be talking about what they're talking about? And along a similar line is, what is within the source's scope and what is within their expertise? Does the source have the appropriate credentials? Are they an authoritative voice in any given field? And thinking about, are they the ones I should be listening to about any given topic? Does the source have a recent history of being questionable? And thinking about, was something once a reputable source, maybe it's no longer, or vice versa, maybe it wasn't originally very reputable, but is now. So really recognizing that this can change over time. Things aren't static, and sources can change, and how we perceive them can change as well. And this is kind of a particular issue that we see today, where data might be disappearing, or things are coming out from various sources where you may have gone for information before, but maybe that source is no longer the most reputable one you can be looking at. And also thinking about, where is the data being presented versus the original source? Maybe it's data or information from one source, and someone else has kind of taken that information and presented it in a different way. So thinking about, where has this maybe come from, or did they produce this? And thinking about the timeline of how that information got from its original source to you consuming it, wherever that may be. And as always, remember that just because you saw it on the internet doesn't mean it must be true. And I'm sure everyone here is well aware of these things, but it can be really easy to kind of get caught up in these echo chambers of sources that you think are reputable, and maybe one bad egg gets in, and it's hard to kind of parse those out from the rest. Also thinking about the purpose of the data itself, or the information itself, and what is it trying to convey to you? What is the purpose of that data or that information coming across your screen? And why is it being presented to you now? Why not yesterday, or why not a week from now? Why is it coming up now? Thinking particularly about conversations that are not maybe like immediate news stories, but why is something coming up now, or why are people talking about that now? It can help you identify if there's any biases or kind of red flags going on there. Thinking about who is the intended audience, and if you are part of that intended audience, it can be easy to kind of look at content that maybe isn't presented for you, thinking maybe it's really health-related research and it's a deep dive into various genetic things, whatnot. And I'm not a geneticist. I don't understand genetics papers. So I know that audience is not for me. And that I can read it, but that I'm not the intended audience for that. So I'm unlikely to take what I'm meant to take from that. And also thinking about, is the goal to convince the users, the viewers, the consumers to buy something or to give someone money? And this is something we see a lot, especially today, where you see interesting information, misinformation that might be coming your way and get to the end of whatever format you're consuming, and it's turned out to be a really long and elaborate ad for a product that they're selling. So really thinking, is the goal of this data and this information that I'm getting to get me to buy something? And also consider the evidence itself, the data itself. Is the supporting data available? So is the data that to back up a claim that someone's made available? Can you click a link and go see it? Are there references cited? And are there references reputable? And also thinking right now, are their references real or are they hallucinated AI references is something that we're also seeing come up. So not only are their references reputable, but do their references actually exist? Does what they're citing exist in real life? Does the data make sense? Is it cherry picked? And what biases might exist in the data? And to do this, it's really important to think or remember that correlation does not equal causation. And this is really easy to get caught up in. I'm sure everyone has seen that shark attacks go up in the summer, as do ice cream sales. So you kind of see them following a similar pattern. But I've chosen a different one here that people maybe aren't familiar with that I learned. That movie releases in the US and Canada also correlates with jet fuel used in Finland. They show a similar pattern, but remembering that correlation does not equal causation will help you pick through these things. And maybe there is a relationship there, but really helping to think through, is the data cherry picked and is it a biased version of the data that I'm seeing here? And a couple kind of mnemonics for spotting red flags. If it doesn't go to 0, that graph is a weirdo. And there are certainly cases where bar graphs might not go to 0, but just some things to keep in mind as you go through things. And I forgot the original video on this one that I'll put the link in before we send the links out, but there's similar ones like this. And if there are no labels, you're being told fables is another good one. You see a lot of graphs that are put out by various different companies where you're looking at a bar graph or another type of graph would have you have no idea what you're looking at because there's no labels, there's no scales available, and it might not make the data incorrect, but it often leads to biases or kind of deceptive practices in data and marketing when you can't really tell what you're looking at. And bad bar size, guaranteed lies, and you get this a lot when the graph doesn't go to 0 on a bar graph, what have you, because it can skew the perception of that scale. So if something starts at 90 instead of 0, and something goes from 90 to 91, and the other goes from 90 to 95, that scale looks a lot different depending on what the graph actually goes to. And another couple mnemonics to kind of just stop and think and help work through what kind of content are you looking at to help kind of build those data literacy skills as you use data out in the wild, as I like to call it, and not just data in your own research. So the crabs one I really liked, thinking about conflicts of interest, references, the authors of something. Buzzwords is a really big one. Do they use words like always or never? Are they making really bold claims that sound weird? And scope of practice, and I did mention these ones kind of previously, but I really like the crabs acronym to help remember these things. And then SIFT as well is another really great one. So stopping, investigating the source a little bit more, finding better coverage of it or finding additional coverage, and then seeing if you're able to trace the claims, quotes, and media to the original context. And this can be really difficult, but it will make you feel like a little bit of an internet sleuth as you're able to kind of go through things and find, where did this originally come from? And maybe you find out that it isn't real, but it took maybe a little bit of time to get there. And that sleuthing can be really important, and that through that process helps build those data literacy skills as well as you kind of go through and think about the various reputability and biases in various sources that you go through in that process. And just to summarize and wrap up, we kind of talked about data literacy in 3 different ways here in 3 different aspects. So thinking about data, and data are very contextual, and they're often discipline specific, and they might even be research project specific. So thinking about what type of data might you be working with, but also what data exists around you. And the data lifecycle is a very iterative and interconnected process. It's difficult to really separate when one stage ends and one becomes the other. You can be cleaning and analyzing and evaluating data all at the same time. And it can be kind of one big step in a research project, but you can separate it out into a couple different skills. And then thinking about unintentional and intentional biases that exist in data, and knowing how to spot them is important, especially in a digital age. And I do want to highlight that these can be unintentional and intentional biases. Some of those biases in the internet or biases in data around us, or even in data in your own research projects, happen unintentionally. You may be unaware of them, or they might be for any number of reasons, but really kind of thinking about, is this an intentional bias? Are they trying to convey something different, or is this an unintentional bias? And just before while we do Q&A, I will highlight that we did include a couple of our top picks for various different sources of voices in the misinformation and data space, people who are we like as creators who talk about various different topics in science and science communication, breaking down complex topics. So if anyone is interested, we've linked a couple of our top picks for various different things here. And we can, if people have questions, I will get Alyssa to please turn off the recording, and we do have some time for questions yet.